Hundreds of millions of collisions every second. Detectors collecting data to analyse 24/7. The LHC and its experiments generate millions of gigabytes of data. The computing grid, a huge worldwide network of computers, was invented to process and store these phenomenal amounts of data. So how does it work? Who uses it? What of its performance 2 years after the LHC startup? And what are its other applications outside particle physics? We're going to review all of this with Oliver Keeble, software engineer at CERN, who works on the computing grid. See you straight away. Hello and welcome to What's New at CERN. Hello, François.
Hello.
Hello, Stéphane.
Hello.
So you're taking us on a journey today?
I'm going to take you to a very noisy place.
Very noisy place. As for you, François, you're about to tell us in less than a minute just how much data the LHC will generate. Can we stock it or store it on USB keys, for example?
We may try, but that's going to be difficult.
In the 4 LHC detectors, around 600 million particle collisions occur every second. This would generate 1 petabyte, this is 1 million gigabytes of computing data each second. Might as well face facts, we will never be able to store this much data. That is why near each detector, electronic and computing equipment will filter only the most interesting data. This will nevertheless generate close to 25 petabytes or 25 million gigabytes of data each year for all 4 experiments of the LHC. That equates to 1,000 years worth of DVD quality video. USB keys would be rather impractical to store this data. It is using the computing grid, which connects dozens of computer centers throughout the world, that we will be able to store the LHC data on hard disks and tapes.
Hello, Oliver. Thank you very much for being with us today. First of all, can you tell us why we call this network a grid and what is it used for?
Well, a grid is a way of linking computing resources which are distributed around the world and making them look like one single resource. So this is computing processors, storage and networks. And it's named a grid after the electricity grid. If you plug something into the mains, you don't know where your electricity is coming from, and it's the same idea that applies to the calculating power of the grid.
But why do we need such an infrastructure?
Well, the LHC produces an incredible quantity of data. And although here at CERN we have a good computer center, it's unfortunately not sufficient to manage all this data. At the same time, high energy physics is a global community. There are many other computer centers all around the world. So the solution is to link them.
And what can you tell us about its performance now, 2 years on after the LHC startup?
Well, I would say, first of all, that the performance is pretty good in the sense that it's working and the LHC is producing data, the physicists are using it, they're producing their papers, etc. We've seen a big change in the use of the grid since 2 years ago when the machine turned on. So the amount of data transferred has doubled, the use of the computing power has doubled, and the number of users has really increased a lot.
And if you could give us a few numbers, number of processors, what are we talking?
Yeah. So there are almost 300,000 processors, or cores in fact, available on the grid, and hundreds of petabytes of storage, both on disk and on tape, in fact.
And on an average day, how many jobs?
Well, we have around 250,000 jobs running at any one time.
250,000. Thank you very much for these insights. François, what's new at CERN this month?
Well, Anna, the recent news for the LHC is the move from proton collisions to lead-ion collisions. So lead ions are lead nuclei containing 208 protons and neutrons. That's what I call heavy. Since 11th of November, the LHC is producing lead-ion collisions, and another record has evidently been achieved. In less than 3 weeks, the LHC has achieved a luminosity 10 times higher than last year's ions round. This is about 10 times the number of collisions that had been obtained for the previous year. But the real first is that the LHC team tested a new operating mode in circulating both protons and lead ions in the machine, and circulating two different particle beams is challenging given the quite different nature of the beams. John Jott explained this when we met him in the CERN control room.
We were able to show on the 31st of October that we could inject some lead bunches with many proton bunches in the machine. And this, I think, for me, was the crucial step. When you have two different beams in the two rings of a collider, it's not obvious how things will work because they have different mass and charge and therefore different speeds. At injection in the LHC, for example, the proton beam will make one more turn of the ring every 8 seconds. So the beams no longer meet each other in the same places. The places where they meet slowly move. We unfortunately had a problem in the PS machine. As a result of that problem, we decided it was too risky to ask for further proton beams for the moment. We did not want to jeopardize the rest of the lead-lead run, so we have had to postpone the remaining part of our test. But we feel that we have already shown that this proton-lead physics mode is feasible and is on the menu for the LHC next year.
And you have further news for us.
Yes, as we've just seen, the LHC is performing very well, and a much brighter future is foreseen. The goal is to increase the LHC luminosity, which is a measure of its efficiency to produce collisions, by a factor of 5 to 10 times by 2020. On 16th of November, the study of increased luminosity for the LHC was inaugurated on the occasion of a workshop that brought together scientists and engineers from European, Japanese and American institutes, with the support of the 7th Framework Programme of the European Commission.
Thanks very much, François. So, Oliver, are the LHC experiments the sole clients of the grid, or are there other applications?
In fact, it's one of the great successes of the grid that high-energy physics isn't now the only user. There are lots of other user communities. The biggest, perhaps now, are the life sciences and astrophysics. I could give examples from recent years of studies that we've seen on the grid aiding the fight against malaria, Alzheimer's disease, and the avian flu.
Oh, those are very interesting examples indeed. Maybe you could also explain to us how the computing grid differs from other information sharing systems like the cloud computing.
So I think that grid computing and cloud computing are different, but they are definitely compatible. So the grid is about sharing and collaborating between different organizations, whereas the cloud computing is a good way for one organization to get more resources for itself. But then it could actually share these resources over the grid.
Okay. So thank you very much for that insight as well. And Stéphane, you're about to unveil where you're taking us today.
Yes, we are going to the computer center of CERN. Follow me. This is one personal computer. And here are 15,000 processors. We are at the CERN Computer Center. This is the place where all data coming from the LHC experiments arrives. This data is stored on tapes, like the ones handled by this robot here. Here, we can store something like 40 million gigabytes, the equivalent of 10 million DVDs. Then the physicists from all over the world can access this information for their research. They use very high-speed network technologies installed at CERN. And by the way, everyone in the area benefits from them, as almost all internet connections in the Geneva area transit through here. The CERN Computer Center is also the starting point of the LHC grid. The grid is a worldwide computer with storage and computing power spread all over the planet in about 150 centers. Thanks to the power of the grid, it's possible to analyze the gigantic amount of data produced by the LHC experiments. Amazingly, we can see the data transfers in real time here. One can also find a very peculiar machine here. This machine, called Next, is not only one of the last of its kind, but it's also a historical item. It's on this workstation that the World Wide Web was invented by Tim Berners-Lee in the 90s. This is the very first web server in history. See you, Anna.
Welcome back, Stéphane.
Thank you.
You're taking us on another trip straight away.
Indeed, I take you first to Paris, where the Hadron Collider Physics Conference took place in mid-November. The LHCb experiment presented intriguing results, which seem to show that some particles, called charmed mesons, do not behave as expected by the model. Data is still under investigation, but some already speak about a door open on new physics. One can find further details on the BBC and The Economist websites. And now some news from the Higgs boson. For the first time, the ATLAS and CMS experiments presented joint results about this elusive particle. The two experiments rule out a new range of energy for this boson. This reduces the windows of energy in which the particle predicted by the model could hide. In other words, we are getting closer. The magazine Nature's say about it, Higgs hunt enters endgame, and The Guardian adds, Higgs boson's moment of truth is fast approaching the LHC. The exploration of other windows of energy carries on, a bit like with an advent chocolate calendar. Note that the ATLAS and the CMS experiments will present their latest results at CERN on the 13th of December this year. Meanwhile, ATLAS made another discovery, a new particle called the Kermit. Muppets Show, the movie, was released in the USA on the 23rd of November. One scene takes place at CERN, and more precisely in the Atlas cavern. It's very short, but it's really great to see the Muppets around the LHC. Let me show you a tiny bit of the trailer. Watch out, it's very quick, almost as quick as a neutrino.
Come on, guys, let's go! Wow, I can't believe it.
The secrets of the universe. I guess we're in.
Welcome to this week's edition.
The movie will be released in February in UK and then a bit later on in the rest of Europe. Voilà.
Thank you very much, Stéphane. New era of celebrity dawns. Oliver, what of the future of the grid and its developments?
Well, short term, I think we have to say that the LHC is working, the grid is in a full operational phase, so we don't want to change too many things all at once. However, a bit longer term, we would like to understand how to increase the efficiency of our use of the resources that we have, and also how to take advantage of new developments in computing, such as cloud computing, multi-core computers, and virtualization.
But if we were to look even further than that, what would the grid of the future look like? Would everybody be able to use it?
Well, more and more communities, scientific communities and others are using the grid, this is for sure. Whether in the end everybody will be able to use it directly, I don't know. But what I would like to think is that everybody can profit from it because of all the research that it allows.
Thank you very much for all this information, Oliver, and for being with us today. Thank you, François. Thank you, Stéphane, for your energy. Thank you all for watching. If you want to see this program again, you can find it on YouTube or on the What's New at CERN website. I wish you all a very happy festive season.